Hi Algebra 2, I hope you're all doing well. So in this video, we're going to learn how to graph the other four trig functions, tangent, cotangent, cosecant, and secant. And we're going to do it sort of the same way, starting off by looking at the unit circle, but only where the unit circle hits the x and y axis. So remember tangent here. Tangent is a ratio of sine over cosine. On the unit circle, that equates to the ratio of the y value over the x value. So we can figure out as we go around the unit circle what the coordinates would be at 0, 90, 180, 270, etc., or 0, pi over 2, pi in radians. Also, I want to point out, I got this little I don't know what you want to call it, acronym, from Pinterest, where it is okay to have 0 on top because that would equal 0, but it is not okay, no, to divide by 0. That is not okay. That would be undefined. On our graph, when you have something that is undefined, that's going to be an asymptote, which we have seen when we did our rational functions. So let's start in on this. Let's look at tangent. We're going to start at 0 radians, which would be right here. This would be pi over 2. This will be pi. This would be 3 pi over 2. And look at what happens. So at 0, I'm making a ratio of 0 over 1, which is 0. So tangent will cross right here. At pi over 2, I'm making a ratio, again, y over x. So that's going to be 1 over 0. Which is undefined. So we draw at pi over 2, we're going to draw an asymptote. Then we get to pi. So again, that's 0 over negative 1, which is 0. And at 3 pi over 2, we also then have negative 1 over 0, which is undefined. So that'll be an asymptote. And coming full circle, get it, unit circle? You're at 0 again. I am going to go backwards. So we're going back into the negative, so going backwards, you're going this way. So at pi over 2, negative pi over 2, again, that's going to be undefined. Then you're going to have 0. Then you're going to have undefined. And then you're going to have 0. Now, how do you do the graphs with all these? So here's another thing that it's really important to notice. We talked about positives and negatives. Remember that tangent is a ratio of the y over the x. So in the first quadrant, where everything is positive, tangent will be positive. So tangent will be, and this is this from 0 to pi over 2, that's quadrant 1. Right here would represent quadrant 2. From pi to 3 pi over 2 is quadrant 3. This would be quadrant 4. And it kind of, in terms of the values, it sort of repeats. This is equivalent to quadrant 4, quadrant 3, quadrant 2, quadrant 1. Okay, so in the first quadrant, tangent is positive. In the second quadrant, since one of the values is negative, tangent will be negative. In the third quadrant, where both x and y are negative, that ratio turns positive. In the fourth quadrant, you have positive, negative. Since one of them is negative, tangent. So that's where tangent is positive and negative. So the way this works is in quadrant 1, you have a positive. So the graph is going to approach the asymptote. In quadrant 2, where it's negative, the graph follows the asymptote, crosses at 0, and then notice in quadrant 3 it goes positive. So what we're doing is the wave. Quadrant 4, it's negative, then it hits 0, and then quadrant 1, it's positive, and it goes up. And then it just basically keeps repeating this pattern. Now, that's graphing multiple cycles, which you do not have to do. So what I want to draw your attention to is from negative pi over 2 to pi over 2. That's what we usually associate with the parent graph of tangent. including the asymptotes at negative pi over 2, so that's a negative pi over 2 to pi over 2. This is the main branch. So notice now, because of that alternating positive negative, it only takes a distance of pi for the tangent graph to complete one cycle, and then it starts to repeat itself. So the period for tangent is pi. Remember, sine and cosine had a period of 2 pi. You had to go all the way around the circle before it started to repeat. So this has a different period, and that's worthwhile keeping track of. All right, let's do the same thing with our cotangent. Cotangent is going to have the same positive negative as tangent because it is just the reciprocal. However, cotangent represents cosine over sine, which means we're looking at the x value over the y value. So what happens here, if I start at 0 degrees, now I'm doing the x value. 1 divided by 0 is an asymptote. So this right here, let me see if I can do a color where you can see, this is an asymptote at 0 degrees. At pi over 2, I'm now doing 0 over 1, which is 0. At pi, I'm doing again negative 1 over 0. So your asymptotes, notice, are shifting by 90 degrees. You're going to have kind of the same pattern where it's going to be 0, asymptote, 0, asymptote. Cotangent, I don't know if you remember from geometry, complementary angles are 90 degrees, two angles that add up to 90. Tangent and cotangent are complementary. They differ by 90 degrees. That's why you shift 90 degrees with your asymptotes. But you can quickly find what they are based on the unit circle, those where it hits the XY axis. Now, utilizing the same quadrants, this though changes, because in the first quadrant, tangent is positive and negative in the second, and we don't have an asymptote between. So what we do is, to do the graph, now you're positive, you're in the above the x-axis, so all the y values are positive. In the second quadrant, you're negative. So it's still the wave, just like tangent, but now it's going down so that it can match the positive negative of every quadrant. And that is what your cotangent graph would look like. And again, the region that we really care about for the parent graph is from 0 to pi. Those are going to be the asymptotes. This is quadrant 1, this is quadrant 2. Again, the period is also going to be just pi because it only takes a distance of pi. This is 0, this is pi, to complete one cycle. So it's kind of like, it's a shame we don't usually, I take you outside, line you up, and we do the wave to kind of emphasize this. So if you want to take a second and do the wave with yourself, it'd be really cool. We should do it on Zoom sometime. Okay, so that is your tangent and your cotangent graphs. The best way to get them, if you don't want to memorize, is just kind of looking at what the values are where the unit circle hits the x and y axis. Now we're going to look at cosecant and secant. The nice thing about them is they are the reciprocals of sine. So what I'm going to do is I am going to do in a light color, I'm going to do a sine graph. So this will be my sine graph. So sine starts at the sinusoidal, remember? Goes up to 1, down to negative 1. So it goes here, then it goes here. And then we can carry it backwards as well. And again, we got these points from the unit circle as well. Those represent the y values on your unit circle at the places where it hits the x and y axis. That's your sine graph. So now let's think about what happens if you take the reciprocal of those values. What is the reciprocal of 0? So 0 over 1, the reciprocal would be 1 divided by 0, which is undefined. So wherever the sine graph hits the sinusoidal axis, that is going to be an asymptote, because the reciprocal of that is undefined. So we can then, and this is exactly how I usually draw it. I usually do a really light sine graph. Wherever it hits a sinusoidal, those will become asymptotes. The reciprocal of 1 and -1 is still 1 and -1. But notice here, down here, like as this graph is getting smaller, the reciprocal of a really small number is a really large number. So the way this graph now works for cosecant is it's going to be parabolas, basically. And they come off of your sine graph and approach the asymptotes. So it's just, that's why I usually do a sine graph. And then I make my asymptotes where the sine hits the sinusoidal, and then we do our little up and down goblets. So your parent, your sort of main branch goes from, actually it doesn't matter where you choose. If you want, let me take this back. I think for cosecant, probably you guys are going to want to choose from 0 to 2 pi. Notice that again, it took 2 pi to complete the whole cycle because you have one up parabola and one down parabola. So the period here goes back to our 2 pi, just like sine is itself. Only tan and cotan have the period of pi. Okay? So if you know how to do a sine graph, you know how to do a cosecant graph. Even if you do all the transformations, I still will draw a sine graph, and then I just do my parabolas off of the high and low of the sine graph. That's the best way to approach it. All right, let's do now your cosine graph. Cosine, actually I want to do it in a really light value, in a light color, so I'm going to do this. Here's cosine. We're going to do it in yellow. So cosine starts high here at 1, then hits 0, it's low here, goes up, and we can carry that backwards. So there's our all. Remember, your cosine goes with the x value, so that just represents where all your x values are on the unit circle. And I can fill it in. And again, if you can just do the dots, you really don't want to fill in the cosine graph. I'm just kind of emphasizing what's happening here. So then, same as with sine, wherever cosine hits 0 on the sinusoidal, the reciprocal of 0 is undefined. So I just go through and I make an asymptote wherever my cosine graph hits the sinusoidal. And same as sine, I now just do my, I guess I could have done it in pink, but you guys will live. Here we go. So I'm just doing my parabolas. Notice it also shifts by 90 degrees from what the cosecant graph was. Secant, cosecant, they are complementary. It's all related. Okay, that would be a full several cycles of your secant graph, and in general we tend to choose, because notice this one, to get the full effect, we usually go back to -pi/2 here, out to 3pi/2. It's still a distance of 2 pi, and that is the graph. If you wanted to do it 0 to 2 pi, where you have kind of that broken upward branch and down here coming down, that's fine, as long as you have a full cycle. It's kind of nice to have the full parabola and the full up parabola and full down, but either way works. Okay, so now that we have done our parent graphs, let's look at how we're going to do the transformations with these new graphs. We're not going to be as heavy on the transformations with tangent and cotangent. We're really only going to look, for the most part, because they don't really have an amplitude, because it's going on to infinity and down to infinity. It just keeps, you know, it doesn't have like a max and a min like sine and cosine. So for the most thing, we're looking at how do you change the period. So what I like to do, I have a little trick for you to make this easier. Your parent graph has the asymptote for tangent at -pi/2 and pi/2. And remember horizontal, which is what this represents. This is your, it's like a horizontal dilation, and this is going to shrink you by a half, because remember it always works the opposite. So the easiest way to do this, it's kind of cheating, but you know what, it works, is since I'm dilating horizontally by a half, that means I can just multiply each of these numbers by 1/2. So I'm really going from negative pi over 4 to pi over 4, and then I do the same graph. It just does the wave and it crosses at 0. And that works. You know, you just, whatever that, when you are multiplying for the horizontal dilation, you're multiplying the x values by the reciprocal of whatever that b value is. 2 represents b. You just then multiply on your scale, and that's it. Notice that now my period goes from negative pi over 4 to pi over 4. That's a distance of pi over 2, which does in fact shrink it by a half because the normal period is pi. So now let's look at cotangent. Cotangent, remember, had a asymptote at 0, so it shifts forward by pi over 2, and an asymptote at pi. And so now this one is a horizontal shrink, or actually a horizontal stretch by a factor of 2. So what am I going to do? Exact same thing. I'm going to multiply. So 0 times 2 is still 0. Pi times 2 is 2 pi. And remember, in the first quadrant, both tan and cotan are positive. So now you start high and you kind of wind down. And there you go. Notice now that your period is 2 pi, which is twice the length of what you would, normal period was pi. So that's kind of my trick. Can you please, however, when you do this, you shouldn't leave this on here. Actually rewrite it as what it is. But that's how I would do it. I would just draw my regular parent graph and then I change my axes. It's kind of the best way to do it. All right, now we have cosecant. So remember, cosecant is the reciprocal of sine. So what I'm going to first do is I'm going to very lightly, in yellow, do a sine graph with all the transformations. So notice we have a new sinusoidal at -1. So here's -1. That's going to be my new sinusoidal axis. I have an amplitude of 2. So if I add 2 to that, I'm going to go up to 1. That'll be, well, actually, I don't want to do the dotted line there. Well, I should. I'm going to. I'm doing it lightly so that we can go over it. And -1, subtract 2, I'm going to go down to a -3. I really should label my axis with a darker color here, though. -1, -3. Okay. Notice that I'm going to start at pi over 2. And I'm going to go a distance, so 2 pi divided by the b value means I'm going to go a distance of pi. So if I'm starting at pi over 2, I'm going to end at 3 pi over 2. That's a distance of pi. Halfway between those is pi, because that's 90 degrees and 270, so 180 is in the middle. Between pi over 2 and pi is 3 pi over 4. You can look at your unit circle to find those halfway points. This one will be 5 pi over 4. And so if I were going to do a sine, remember sine starts on the sinusoidal, which is here. I'm only going to do the dots. I'm not going to do the graph. Then it would go high, sinusoidal. It would go low, sinusoidal. If I were to draw that in, that would be our sine graph. But we're not doing a sine graph, we're doing a cosecant. So what I'm going to do is wherever my dot is on the new sinusoidal, that's going to be an asymptote. Then I go to the high point and I draw my parabola coming off of that high point, because the reciprocal of 1 is 1. The reciprocal of -1 is a -1. And that would be one cycle, one period of our cosecant graph. All right, so it's really, if you can do a sine graph, you can do a cosecant graph. So now let's do the same thing for secant. Remember, secant is the reciprocal of cosine. So now let's see what we got going on here. I have a new sinusoidal at 2. So this is going to be my new sinusoidal axis. I have an amplitude of 3 that is reflected. Oh, sorry, I didn't even notice these boxes at the side. My vertical translation, that was -1. That's your sinusoidal. My amplitude was 2. My period was pi. Phase displacement, where I start, was pi over 2. So this one, new sinusoidal's at 2. My amplitude is 3, but I'm going to be reflected because of the negative here. My period, so 2 pi divided by pi over 2 turns into 4, because the pi's will cancel, invert, and multiply. So that's going to be a distance of 4. And I'm going to start at 1. So that's where you start, the phase displacement, which means I'll end at 4 plus 1, 5. Okay, so let's label our axes. So we know that this will be at 2. I'm going to go up 3, down 3. So that's going to put me at 5 and at -1. There's my y-axis. I'm going to start at 1 and I'm going to end at 5, because my period is a distance of 4. So 5 plus 1 is 6. Half of 6 is 3. Oh, this one's really easy. 1, 2, 3, 4, 5. Yay! Okay, so I'm only going to, again, do the dots for the cosine. So cosine always starts high. So at 5, it's going to start up here at 1. Then the sinusoidal. Then it's at the low. Then it's on the sinusoidal. And then it ends high. So we know that wherever I hit my sinusoidal, I'm going to have an asymptote. And I would really like to have more than 1. So it does turn out that this is going to, since everyone's a distance of 1, that's going to be an asymptote too. And then I do a parabola off of the high, parabola off of the low, and if you wanted to, you could keep going. But there, if you can do a cosine graph and set those 5 dots up, you can do a secant graph.